Vice President of AI and Machine Learning, and work on building real-world AI solutions and leading teams and turn ideas into impactful tech. I'm excited to be at Conf42 and share some of the work we've been doing. Securing AI-driven financial operations and systems at scale. Investment banking operations demand bulletproof security alongside efficiency. This presentation reveals how we implemented a security-first strategy against agentic AI framework and transforms middle office operations into enterprise-grade security standards. The security imperative. The challenge: financial institutions face an uncomfortable truth. Traditional security frameworks were never designed for the complexities of agentic AI systems. Every AI capability introduces attack vectors that didn't exist in traditional systems. For a secure system where decisions emerge from probabilistic models rather than deterministic beliefs, how do you maintain compliance when AI agents autonomously retrieve and synthesize information from vast knowledge bases? And we're security must be embedded in the architecture, not bolted on us. This means treating every component of the AI pipeline as a potential vulnerability and designing accordingly. Careful architecture, rigorous DevSecOps practices, and continuous refinement. We create a platform that processes enormous transaction volumes while maintaining security standards that exceed industry benchmarks. Three-layer security architecture, varying knowledge retrieval, multi-tiered knowledge base with segregated domains, each maintaining access control encryption schemes, mechanisms, dynamic security posture, adjust measures based on information sensitivity, basic orchestration. Multiple specialized AI agents collaborate within strictly defined scopes. Blockchain-inspired consensus mechanisms for high-stakes decisions. Zero trust model with end-to-end encryption between agents. Good-amount processing pipelines. Sandbox environments with no direct access to production systems. Multi-stage input sanitization and output validation. Air gap approach prevents compromised models from code. Data security, multi-layered protection, and underlying implementation corporate security at every step of the retrieval process. When the AI is the knowledge base, the request passes through multiple validation layers before any information is released. Identity verification, agent identity, and authorization credentials. 2. Query sanitization. Sanitize queries to prevent injection attacks. 3. Access control. Role-based control to limit retrieval information. Flag every interaction for compliance and flag secure transmission. You can retrieve information through transmission. Agent orchestration and consensus on zero trust specialized agents. Shared validation, compilation, risk assessment, peer communication, exception handling, operational. Each agent operates within strictly defined scope. Principles of least privilege. Consensus mechanism. High stakes decisions require agreement across multiple specialized and execution agents proposing action and compliance. Risk and operation agents must independently work before execution proceeds. Integrating security seamlessly. Proactive automated security testing. Cool. Comprehensive security testing from the earliest stages. This includes static gun analysis and the testing and isolated sandboxes. Continuous automated penetration testing and fuzzing to identify vulnerabilities before deployment. Secure infrastructure as code, also known as IAC, defines security policies, access controls, and encryption configurations directly as version code. Ensures consistency, reproduction, and compliance across all the development, staging, and production environments, eliminating embracing shift-left security, embedding considerations and practices into the development lifecycle, using secure coding templates, and test integrations. We make sure the development is the most efficient adoption path for engineers. AI model security, from training to development, training data curations, carefully curate training data to avoid incorporating sensitive information, bias, or examples. Training occurs in isolated environments with no network access. 2. Nodal validation. Security benchmarks demonstrate resistance to known attack patterns and consistency with previous versions. Cryptography, silent store and secure deployment controls, rigorous validation processes before production, multiple navigate from security and compliance teams required. 4. Continuous monitoring, shrink performance metrics, data drift, and conceptual drift. Regular backtesting validates models continue to perform as expected under current conditions. Real-time threat detection. AI securing millisecond speed. Our threat detection system operates on multiple timescales, simultaneously perform real-time analysis for every transaction and system interaction as occurs. Machine learning models examine transactions, metadata, user system file patterns, network traffic, and data patterns by within seconds. 1 million are security events daily, processed with sub-millisecond response, 8% detection accuracy, high fidelity alerts with minimal false positives, millisecond detection rate for most threats. Multimodal detection approach, statistical models, identifying deviations from baseline behavior patterns. Deep learning, recognize complex attack signatures and failures. Graph neural networks, detect unusual relationship patterns across systems. Reinforcement learning, adapt to evolving threat landscape dynamics. Combining these approaches, we achieve both high detection rates and low false positive rates, maintaining operational efficiencies while ensuring comprehensive security coverage. Tier alert system, low severity, automated defensive response without human intervention, additional authentication requirements, rate limiting, enhanced learning, restrictions. Medium severity, notify security analysts but allow operations to continue under increased monitoring, gather additional forensic information, monitors and escalate to senior security staff, acceptable, legitimate, compliance and guidelines, investment, government transaction reporting, DRD frame, risk management, GDPR, data protection standards, treating oversight, AI risk management frameworks, explainability strategies, multiple explainability approaches tailored to different audience, regulatory, audit trails with input data, reasoning steps, and decisions, technical architecture, feature importance, sensitivity analysis, business, simplified explanations focusing on business logic, performance at scale, security or faster, system availability, maintained across all operations, long query time, even with millions of documents, daily transactions, process with security checks, transaction latency, including security validations. Through intelligent caching and optimized architecture, we have proven that security and performance are complementary rather than competing objectives. Our system maintains some-second response times, seeing extensive security checks on every operation. Key lessons learned: security from inception. Retrofitting security into an architecture design without it is far more difficult than building security from the start. Treating security as first-class requirement aligns with functionality and performance. Human oversight remains critical. The right balance involves clear delineation that handles autonomy versus the requires human judgment with rapid escalation paths. But encounters uncertainty. Cultural success requires transparent communication, training programs, involvement of operations staff, and AI system design, and demonstration of AI rather than replaces human expertise. Adaptive defense. Threat landscape evolves constantly. Security systems themselves must learn and improve. The regular red team exercise, participation in security communities. Future directions. Emerging technology, federated learning, improved models without centralizing sensitive data, encryption, and reputation and encrypted data. Quantum computing, accelerate AI operations, and prepare for quantum industry standards, develop shared frameworks for secure AI agent communication. Regulatory evolution. We anticipate more prospective requirements for AI government standardization of explainability, expectations, and international coordination on AI regulation. Building the future of secure AI. The transformations of financial operation to AI is not future possibility. it's happening now. Our responsibility is to ensure that the information is strengthened rather than weakness. The security posture of financial institutions start with security. Security throughout your architecture from day one. Continuous process. Treat security as ongoing evolution, not destination. Invest in culture. Build the people and culture needed to make it work. Responsible innovation. Embrace AI's potential while maintaining security and reliability. The security first evolved from our pioneer, then demonstrates that we can embrace AI's transformative potential while maintaining the security and reliability that financial operations demand. The journey continues and we invite others to join us in the building of the future. Secure, intelligent financial outcome. Thank you. For any questions, please reach out at LinkedIn.